On STAR, prime factorization has been tested in a fairly creative way. Okay, so I want to show you that. So far, you have been asked to find the prime factorization of a number. Some of you have gone backwards and used the prime factorization given to find the original number. Okay? On STAR, they have asked before, what number is missing from this prime factorization for 700? Okay, so you could still go either direction. I recommend you always do your tree and find your prime factorization. I'm going to show you how to manage that to find your missing number. Okay. It's much easier than using your answer, but I want you to have all of the tools that you can. You could figure out what it has so far. So 2 squared is 4 times 7 is 28. And then figure out 28 times what needs to be 700. The only problem is if your what is not prime, you'll have to break it down into its exponent. Okay? That might have sounded like gibberish to you. So let me tell you. If you need to find a missing number, solve your prime factorization and find what they left out. Okay, so for 700, I know it is even, so it can be broken up by 2. And half of 700 is 350. Okay, if you're not sure, you could out to the side do 700 divided by 2. All right, 350 is also even, or you could do 350, I know it's divisible by 10 because it ends in 0, and it's 10 times 35, okay? Because 10 times 35, you just add the 0 and it's 350. So 35, neither of these are prime, so I'll keep going. 10 can be divided by 2 and 5, and both of those are prime, so it's done. 35 can be divided into 5 and 7, and both of those are prime, so it's done. All right. So we have a 2, I have 2 2s, so I have 2 squared, times 5s, and I have 2 of them, it times 1 7, okay? So what we're missing from up here, they have this one, they're missing their 5 squared, all right? All right, you go ahead and do your own. Practice what we just did. Remember, your number is 360. You're trying to find the number that's missing from its prime factorization. So what you need to do is make a factor tree from 360 and find the number that they left out. All right. My branches might look different than yours, but my end answer should be the same. 360 is even, but it's also divisible by 10. And I know 10 times 36 gives me 360. I'm going to keep going. 10 can be broken up into 2 and 5, and both of those are prime. Okay. 36 can be broken up into 6 times 6, and both of those can be broken up again into 2 times 3. And 2 and 3 are both prime. Okay. So that is it. I have a 2. I have 1 2, 2 2s, 3 2s, 1 2 3 2s, so 2 to the third, times a 5, done, times 3, and there's 2 of them, 3 squared. Okay, so in theirs they have my 2 cubed, they have the 5, they are missing the 3 squared. Okay, so the number that was missing was 3 squared.